So we are back with successive percentage changes. There is another application of that. So the application goes like this. So if you have two quantities, so let us say we have two quantities P and Q, and their product is, let us say, something like A. Okay. So P times Q is A. So now if P's value changes by X percent, Q's value changes by Y percent. So for A, the percentage change will be that formula which we had done under successive percentage change. Now why is it like this? The logic is simple. See, if you had A equals P times Q and P changed by 10% means P's value will become 1.1 P. Okay, I'm assuming 10% change here. And here let us say 20% change. So this becomes 1.2 Q. These are anyways getting multiplied. So we are going to multiply them. That's a new value of A dash. So now if I have this, simplify, it is 1.1 times 1.2 times PQ. But we know PQ is A only, right? So what do we have? A dash is 1.1 times 1.2 times A. Means the value of A has become 1.32 times. So the percentage change is 32% because this value is 1.32. Now we might very well have just used this instead, 10 plus 20 plus 10 times 20 over 100. So this is the application. If you observe anything where any question, any scenario where two things are multiplied to give you a third, percentage changes of these two are given, you have to find the overall, then just use the successive percentage change formula again. Let us check a question and see how we can apply it over here. Okay. So this one's, let's take a CAT question. So reading comprehension section. So you see that this guy can read 4 passages in 48 minutes. It's too slow, right? So now by what person should he increase his speed so as to be able to read the passage in 20% less time? Now you guys might be thinking that, okay, we need to figure out 20% of 48 and then do a lot of stuff with 4 passages and stuff. Frankly, the point is this data is useless, irrelevant. This data is irrelevant. What is the only important part is 20% less. And you have to understand that we are talking about speed and we need 20% less time. So the number of passages that you can read is the rate of reading. So reading speed multiplied with the time that you have available. So the same thing as we were discussing, P times Q is the quantity. Reading speed is, we don't know. That's the question. By what percentage should you should he increase the reading speed, right? Now it's saying that you have to be able to read the passages. So it's the same number of passages that you have to read, right? In 20% less time. So that means here you have minus 20%. What should you have? Let's say X percent. So that the number of passages don't change. We are not changing the number of passages, right? We are not saying 5 passages, 4 passages, 3 passages, the same number of passages. So 0 is equal to successive of X and minus 20. So let's solve it. X minus 20 minus 20x over 100 equal to 0. Now this is 1/5. So x minus 1/5 of x is 4/5 of x. So 4 over 5x is 20. So that gives you x to be 25%. Means if you are able to increase the speed by 25%, the reading speed, you will be able to use only 20% less time and be able to read the same number of passages. Now, there are other methods of also solving this where we can just simply avoid using successive percentage changes, just using ratios. But then that we'll take up in some other video, not in this one. Thanks for watching.